All right. To do the examples and the tutorial questions, you will need to always constantly refer or remember these equations. All right. And also, please get ready your appendix. Okay, the appendix PDF or the hard copy if you do have it. So I give you some time to go and get your appendix or get ready before I move on. Okay. If not, you can pause it and then continue the video. If not, I'll go to the next slides and move on to the example questions. The questions are available in the PDF slides format also, so it's easier for you to refer to if you want. All right, this is example one. So the example one mentions that they extract the catalog CR for a ball bearing, all right, to be 42.3 kilonewton. That means from the catalog, this particular bearing, okay, they recommended to you, okay, has a 42.3 kilonewton CR catalog and a rated life of 1 million revolution if you apply 42.3 kilonewton. Okay, so what would be the expected L10 life if your factory setup has a radial load of 21 kilonewton? That means from this diagram, the bearing is rotating at a constant speed, all right, and your factory loading is 21 kilonewton radial load. So your allowable CR of the bearing is 42.3 kilonewton. This is extract from the catalog, all right. The catalog told you that because you selected the bearing. Then due to only one radial loading, there's no axial loading, so your FR is equal to PR. Please remember that. Okay, when this particular case or problems you encounter, there's only one radial load, then your Fi is equal to PR, which is 21 kilonewton. So using the equation L10 CR over PR to the power K times 10 to the power 6, you know your CR, which is from the catalog, you know your PR, which is your factory loading, and your K. K, what is the ball bearing of K? Please go and find out. You substitute in all the variables, you multiply, you'll get it out. 10 is equal to 8.17 million revolution. That means this bearing will fail around after 8.17 million revolution. Failure starts to occur, and it will be advisable for you to change the bearing before 8.17 million or on the 8.17 million revolution. So this is the calculation. It's about simple example. So let's move on to example 2. Example 2. Compute the required basic dynamic load rating CR. Now in this case, they want you to calculate the CR. All right, for a ball bearing. So given data will be to carry a radial load of 3 kilonewton from a shaft rotating at 600 RPM. To give you the revolution that is part of an industrial blower in a manufacturing plant. So the shaft will support and rotate, okay, at 600 RPM. So the design life is to be at 30,000 hours. All right. So instead of revolution, now they give you the design life, the L10H. So from this formula, L10 revolution equal to L10H times revolution and times 60. So you have your L10H 30,000 hours, you have 600 RPM, you convert it to hours, you multiply it into it, you will get your L10 in revolution. Right? So I get my L10 in revolution. So formula given CI is equal to PR L10 over 10 to the power 6, 1 over 3. Okay? How do I obtain this formula? Is actually from this L10 formula. You just need to make your CI as the main core. So you will get this layout. So from the diagram here, schematic diagram to explain to you, this is the ball bearing. We want to calculate our CR and later using that to determine what is the suitable bearing from the catalog. So we're going to calculate our CR. All right, so your revolution rotating speed is 600 rpm, L10H is 30,000 hours, and there's only one radial load, so your Fi is equal to PR, which is 3 kilonewton. So I already mentioned how I get my L10 revolution. So what I need to do is substitute in my PR, which is 3 kilonewton. My L10 is 1.08 times 10 to the power of 9. Okay, if you times 30,000 times 600 times 60, you will get this value, 1.08. Okay, times 10 to the power 9. Divided by 10 to the power 6 to the power 13. Okay, then you punch in the number, you will get 30.78 kilonewton. Okay, this is your calculated CR. That means you calculate based on your factory loading and the type of revolution L10 you want. So you will choose the ball bearing with dynamic loading rating CR. That means this catalog CR must be greater than your calculated CR. So you later, based on the catalog, you must look for something more than 30.78. That means 31 kilonewton and greater will be good. Okay, so this is example 2. This example 2 shows you how you calculate your CR based on your factory loading. So this is just a typical data from Mechanical Engineering Design Handbook, recommended bearing life. So if it's an industrial blower, so your lifespan will be 20 to 30. Okay, this is to the power 10 times power 3 30,000. So that is the range that we are looking at. All right. So this is life expectancy in hours for the blower bearing. Okay, so let's move on. All right, example 3 is a continuation from example 2. So example 3 is asking you to select a single row deep groove ball bearing to carry the 3 kilonewton of pure radial load from a shaft that rotates at 600 rpm. This is the same data given in example 2, and the design life is 30,000 hours, same from example 2. So it's the same thing. Then the bearing is to be mounted on a shaft with a minimum acceptable diameter of 38 mm. So from here, it's telling you that I want a minimum 38 mm diameter shaft. So minimum, I can choose 40 or beyond. All right. So my calculated CR from the example 2 is 30.78 kilonewton. The bearing bore diameter selected is 40 mm, as because of the minimum acceptable diameter given is 38 mm. So I choose 40 mm. All right, 40 mm. So you go to A3-2 catalog. Okay, page A3-2, your appendix, page A3-2. The catalog will tell you that it's a deep groove ball bearing catalog. Okay, on the top, you will see is a deep groove ball bearing. Make sure you refer to a right chart A3-2, and you go to the column where on the left hand side stated is 40. That is where it tells you the ball diameter. All right, so we will select the bearing number 6308. Why? Because you run down 40 is actually the ball diameter, so you identify here, so you just concentrate on the 40 side. So my calculated CR is 30.78. Correct? This is my calculated CR. So on the fourth column, there will be your CR stated here, and the right hand side is COR. Okay, so we look at the CRs itself. The CR itself is requires 30.78, so 30,780. So you look at it, 22,400 is lesser than 30,780. So the next one is 31,000, which is greater than 30. So I will choose this ball bearing because the catalog CR is definitely greater than the calculated CR. So the ball bearing number is 6308. So you can go to the manufacturer, or you can ask your material purchaser to say that to order the bearing number 6308. You just tell them I want a bearing 6308. So based on that, they will tell the manufacturer, and the manufacturer will give you a bearing 6308. Okay, the next slide is referring to the exact bigger table A3-2 deep groove ball bearing. Okay, it's from the appendix. All right. So if you were to look, have the appendix in front of you at page A3-2, you look at here, this small d, right, is actually referring to the bore diameter. So we need the minimum, the question given is minimum 38 here, as stated here. So 35 is smaller than 38, so we can't accept it. So we go to the next level is 40. You can't, there's no 38. That means what I'm trying to say is the manufacturer only manufacture 28 mm bore, 30, 32, 35, next one 40. So you want a 38 can, you gotta pay a very expensive price to kickstart the production to just manufacture a 38 mm shaft diameter for you. So sometimes cost is the issue, so we will choose the next available 40. Then this is where just now I mentioned the dynamic CR. Okay, the dynamic CR. So your calculated CR is 30.78. Then based on the column here, what you're interested is 40. So ignore the rest. Ignore the rest. So you look at 40, start from 6808. Okay, you realize that you see the 89023. So the second digit tells you what type of duty the bearing can provide. So in this case, our calculated CI is 30.78. We choose 31.5 kilonewton. So 6308 is our answer. All right, 6308 bearing suits our requirement. All right, next video we will talk about or we introduce usage of nomograph